Peekaboo. Peekaboo. Where did I go? Peekaboo.
All right. So today we get to talk about rhombuses.
Rhombi.
Rhombi. So you're gonna want a ruler.
Are both of them correct, or is it only
No,
wrong?
rhombi is what we should say.
Okay, then I'm gonna call
Like
them wrong.
octopi. There's no back
You
to
can
this
say
paper. Please don't
octopuses.
look.
You can't say octopuses. Also,
There's no back to this paper. Please don't try to see if there's a back. There's no back to this paper, Mr. Estes. No back at all. Stop.
There's a back.
Stop.
It's an answer key.
Alright, so let's
Wait,
start.
it's an answer key I think we already have.
Mr. Hudson, I never would have looked on the map if you hadn't said that.
I would have.
I might have.
See, we have. It's like Goldilocks and the Three Bears. I would have. I wouldn't have. I might have. It's too hot. It's too cold. It's just right.
I'm the baby bear.
So use your ruler, not to smack yourself in the chin, but to draw the diagonals of these rhombuses. I also would like you to label anything else that we know about the rhombuses.
Oh wait, the diagonals are the lines that go like across the middle, right?
It is from vertex to vertex that is not an outer edge. Hey, don't be bad people. My friend's house has been broken into a couple times, and last night they finally caught the guy and arrested him. So don't do things that end up
One
sending
guy
you to jail.
did it multiple times.
Yeah, well, when you do it, and the first time you did it, there was no security system or anything. You just broke in and just took stuff.
How did they?
Why would you hit the same house multiple times? That's
Stupid.
like the lesson here, actually.
One
If
thing
you
my
get
dad
rid of your house, don't
always
do it
repeated
multiple times.
was criminals are stupid. Like, he said that so many times when I grew up.
Well, yeah, because they don't want to put the hard work in and like get money. So
Wait,
easy
I forget,
solution.
are all the sides congruent or just the pairs?
What?
That's for you guys to discuss with each other.
Or
Only
sides?
the pairs. Wait, for what?
Or congruent sides on a rhombus.
Let's check.
You also have rulers in front of you that you could check the
You
measurements
said
since.
never trust what it looks like, Mr. Hudson.
Yeah, but if you measure it, then you
Like
measure
it's a
it.
shape.
That's the excuse
It can't be not a. Well, I guess technically the lines could actually not be parallel, and they wouldn't be rhombuses.
And Akshay is over here looking stuff up in her textbook she paid for.
I did not pay for it.
Imagine paying for a textbook.
I didn't pay for it.
Kind of nerd-like, you know. Wait, we should get protractors too.
See, I was about to say, you guys are the ones who are always arguing use a protractor. Now I'm trying to tell you to measure something.
That's what I was saying. I was saying that's the argument Connor always uses.
So the question is, since I've told you that these are rhombuses,
How do we
what
know?
does that inherently, assume?
All of the sides are the same.
All of the sides are the same?
No.
Because they were having the debate of, is
No,
it...
It says it.
No, they are.
Oh, is that what a rhombus means?
Ah.
I don't know what a rhombus
So let's go ahead and label that all of our sides are congruent for each of these shapes. So use one tick mark or whatever you want to.
I also thought he was talking about the interior distances. Not the-
Ooh, the diagonals? We could measure the diagonals too.
We don't have to measure them. We already know.
Are they going to be equal?
To the sides or to each other?
I don't know. Connor's the
They're
one.
gonna be equal
Connor's
to
the one who
top.
opened this door.
They're not going to be equal to the sides because I know that.
They're equal to each other, I think.
From what?
No, they're not.
When you measure in squares, the diagonal distance is like slightly more than the like straight distance.
No,
They're
that's
the
not
same.
what I was
They're
talking
the same
about.
number of tiles diagonal.
No, I was talking about the parts of the. I was talking about how they bisect each other. You know, bisect.
My good ruler
I'm
went
gonna say
somewhere.
all lines that bisect.
I gave my good ruler to somebody. So if we look at the fourth rhombi there, it really looks like those diagonals
It's a
are not equal
scaling
to each other.
rhombi.
I don't think you can have a scaling rhombi.
Oh, you should never trust what it looks like.
Don't judge a tuck by its color. You know?
Okay.
You know that expression?
No, that is definitely an expression.
Yeah, don't judge a tuck by its color. Wait, are these all How?
I don't know.
How? Okay, now I can.
Rhombuses.
Rhombuses. Oh, yeah, that makes sense. Okay, well, we know. Guys, I'm gonna bring forth a wild theory. The things that look like right angles are left angles.
Oh my god.
I know.
Game theory.
Game theory? Mr. Hunt, did you watch Game Theory?
I do not watch a whole lot of things.
Did you watch No Way Home?
I did not yet. It's still just in theaters, right?
Yeah, how did you watch it?
Technically,
She pirated it.
okay, first of all, you can find it on TikTok. Second of all,
So video piracy.
That's still
Yeah,
pirated.
that's still piracy.
I'm not doing it. The other person did it. I just wanted to watch it. That's okay.
That's
And then my cousins downloaded it. I don't know.
Video piracy.
I would maybe be careful what you say since you're being recorded right now.
Yeah, you
Crap.
doesn't have a legal name. She's actually not a citizen of the United States.
We
She's
call her-
Finley,
Call her Cruella
who
DeVille.
doesn't go
That's-
here.
That's worse.
You don't even go here.
You don't even go to school here. You're just here. No one knows.
Yeah.
All right, so at this point, our paper should look something like this. We've got all of the edges congruent to each other. Now, let's not be like crazy overly, like this does not mean it's congruent to that, right? It means that it's congruent to in its own shape.
I measured the first
Well, like they could
all
be.
of the bisecting things.
Now, so
You know that.
these look like right angles, but this is a question that we have.
We proved that with kites that they are right angles.
Well, is a rhombus a kite?
Yes.
Wait, so to be a kite,
Wait.
are we
guys,
saying a rhombus
I'm
is a more
confused.
particular kite? Like kite would be up above it, and then rhombus would be like, we're doing like a flow chart of shapes. So we have
that's
like,
how it is. I saw it on the Ohio State test on the answer key. So yeah.
so we're in quadrilaterals, right? So in quadrilaterals, what made a kite a kite?
It had two sets of congruent adjacent sides.
So two sets, two pairs of congruent sides.
It's also a parallel. Oh, it's both a parallelogram and a kite. Wait.
Yeah.
Which is the more.
You
Wait,
get
so
a
you're
kite,
saying,
you get parallelogram, rhombus.
so you're saying rhombus is kite and parallelogram?
Yeah. Because it's two adjacent sides and two opposite sides, which by substitution makes the fourth side also.
So kite and parallelogram at the same
That
time?
looks like a logarithm.
Yeah, I know. So you're saying that this is parallel to this.
And same thing for the other two. They're parallel to each other, not upright, like brain of Cthulhu plus one. Oh, yeah, you're right.
So, okay.
It's like brain.
What else? If we're saying that a rhombus is a kite, what else did we say about kites yesterday?
They're cool.
They're cool.
Oh, wait, then things make right angles. I forget how we proved it, though.
Because they're bisecting, so they have to be like.
That's not what it
Just
said.
watch the video from yesterday.
Yeah, that's not a good explanation.
No, wait, yeah, so we proved in a kite that the one line has to bisect the other line. Because they're
Yeah, but that doesn't
equally
matter.
distant.
Remember, I specifically remember Mr. Hudson saying bisecting doesn't matter.
Well, the one line got bisected, but the other one didn't. That was the thing.
Oh, yeah, it had to do with, like...
It had to.
Triangle.
They bisected it, so it had to be in half, and it was a linear pair, so it had to be 90-90 because that's the only way two things that have to be the same bisect.
So
And also,
these
Oh, yeah.
are vertical, right? So we said vertical angles have to be congruent. These, the one tick and the two tick, are linear.
Yeah. And the two tick and the one right next to the two tick have to be the same because it's half.
So
No,
that,
CPC, sorry. And we know they're congruent because we know the one line has to be
Okay. So then, is there a way to prove that both of these have bisected? Like that this
You can use
and
your
that
blue chapter.
and this and that. Not even
Yeah,
angles,
you can
but
do
so
it
they were talking about
sideways.
bisecting the diagonals, right? I
True.
think.
Because CPCTC though.
Yeah, and then you have SAS.
What do you mean CPCTC?
Like, okay. I'm coming up to the board.
You gonna start drawing in colors?
So this side congruent to that side. We all know that. This side congruent to itself. We also all know
Use
that.
the colors.
And this side, well, we're trying.
So wait, at this point we've said all of these are equal to each other, so I should mark all of these the same.
So this line cuts this angle in half.
How do we know? How did we say that?
Okay. And then continue.
Because we drew that one.
Yeah.
We can say that it does that.
Yeah! Wait, that's not quite how it works.
I don't know if that counts.
I
Like
just
it
made
does,
You can use a
though.
ruler.
It's called the because I said so here.
So
Dude, love that one.
If you make a line, then you get.
if I draw a right trapezoid and I go from vertice to vertice, that's an angle bisector? No.
Depends
So-
on what kind of right trapezoid you draw. Wait, no, I don't think it ever could be. Like, is there a way? If your right trapezoid's actually a rectangle.
So wait, you said go back to yesterday's video, and I'm not going to go back to yesterday's video, but I can go back to what we wrote yesterday.
Oh.
So we said
I'm loving it.
we did all of this, right?
Yeah. How did we prove it bisected? Oh, because it already told us.
Hey Jake,
Oh!
rein it in.
Because a kite's made up of two congruent triangles.
Wait.
yeah.
No.
Oh, the congruent triangle thing we did at
And
first.
you already told us it was a rhombus.
I said SAS. SAS.
So wait, if we back up and just look at like, okay, I haven't drawn on this one yet. Can I prove that this triangle on the left is congruent to this triangle on the right?
Yeah, you just reflect on it.
Yeah, side, 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 right? Reflexive, and then we said that's congruent, and that's congruent. So those are congruent triangles.
I was like, you could just reflect it over. No, like, yeah. Okay.
You could, yeah, what you're saying is true.
Oh, yeah.
Would these be congruent?
Sure.
Top and bottom. Except I don't know where my blue highlighter went to.
No, wait.
Yeah. That's really right.
So you know.
Because side, side, side again, right?
Yeah, all of them have sides.
So we know that the angles are all like good.
The angles are all like good.
Yeah, like.
Well, if these are congruent triangles, I
Has
think
to be congruent to this angle.
Yeah, I think what
This
you're
angle
saying
has
is
to be
this
this angle
is congruent to that.
Yeah.
Similarly, this is congruent to that, and they may not be. Well, wait. Are these going to be congruent to all of each other?
Yes.
Not unless this is an isosceles triangle.
Is it?
I don't know.
Yes.
How?
Yes, because the two sides are congruent.
Boom, diddy, boom.
Oh.
That silly Willy.
So these angles are all congruent to each other because we had isosceles congruent triangles. With me?
Yeah.
So then, guys, you are going to be asked to do this on a test. So if you won't be able to remember this on your own, you might want to start taking some notes. Same thing if we look at the triangles that were on the left and the right. They're isosceles, right? So this base angle will be equal to this base angle because of isosceles, and because these are congruent, those will be equal to each other. So now we've actually proven that these diagonals are angle bisectors.
And we've also proven that all those triangles are congruent.
So we've also proven all the big triangles are
And the
congruent.
corner ones. Well, maybe we haven't yet, but like angle, side angle.
Angle, side, the side I just drew. Angle, angle, side, angle. Ah! Yeah, they must be congruent to each other.
And the ones on the bottom too. It's also angle, side.
Actually, yeah, they're all congruent to each other, right? Not just pairs.
CTCGC, the corresponding sides of the congruent triangles are congruent. I love it.
So you're saying this proves
This video is not sponsored by McDonald's.
what does this prove though? I think you just said it, but we need to formalize it.
By corresponding part. See, if you take the side that is one tick, no tick on each of the triangles, that side's congruent. And that side for each of these triangles is the middle. So it proves that this line bisects that.
So if I make that, I don't think I've used 3 yet. If I make that 3, then this is 3 because these are congruent triangles. This is 3. This is 3 because we said those are all congruent to each other, which means that is congruent to that. This is congruent to this, which tells us what about this point?
It's the middle of both those lines.
That's the middle of the rhombus.
It's the bisector of both of them, right? It's the midpoint of both of the diagonals.
Of the rhombus.
I feel like that might be useful.
Probably.
Wait, so are all of those tick marks, are all of them 3 or just 2?
No,
of them?
these are 2.
Okay, that's what I thought.
Wait, is there a way to like actually use that to like figure out the middle of a rhombus if you have to like?
This is actually a very special point.
The middle.
You guys ever heard of orthocenter or circumcenter or
Yeah.
What?
circumcenter or orthocenter?
Like 4 of them.
Nah, I'm not orthodox. I'm Roman Catholic.
Right?
Actually, I'm atheist.
I was about to say, aren't you atheists?
Yeah.
I think we've had this conversation.
Yeah.
Because Connor screams every 5 seconds, I'm a toxic atheist.
You're a. Did you say you're a toxic atheist? You're a what?
Toxic?
Now the song is the
Yeah, I was about to say. Now I'm just thinking of Britney Spears. All right, grab a seat real quick. So what else? So wait, actually, I asked a really good question. Is this side congruent to that side, or really this section congruent to that?
Not unless you start with a square.
Ooh, is a square a rhombus then?
Yes.
I think the definition of a square is it's
So-
a rhombus.
Rhombus would continue down, and you said square is under
Is
here
rhombus
somewhere.
plus rectangle. That's what we learned in my
Is a
first
rectangle a rhombus?
No.
Ooh.
Not unless it's a square.
So rectangle is not a rhombus unless it is a square.
Yeah.
So if
rhombus
we go
plus
ahead,
rectangle.
Squares are so special.
if we go ahead and say that this is a square,
Because it looks like it.
then we can start to say some things about the diagonals of a square.
They're the
They're
same.
all equal.
That equal to that, equal to that,
How
equal
do
to
we
that.
know this is
Well,
a square?
actually,
Because you use the ruler, all the lines are 3 inches.
But how do we know it's a square?
I mean, if
Because
the
I
lines
used a
measure to be
ruler.
the same size, it actually doesn't matter what size they are. If you have a straight edge, right? You don't need a ruler. If you have a straight edge and you measure out and say, this edge is
5
from
centimeters.
here to here, right? And then I apply that straight edge to the other sides, I can prove that all of these are congruent to each other just by using a straight edge.
Yeah, but that doesn't make it a square.
Wait a
Yeah,
second.
That makes it a rhombus.
What do you mean that doesn't make it a square?
So Jake's right with what he said. Congruent sides doesn't make it a square because all of these have congruent sides.
Protractor time.
Congruent diagonals makes it a square.
So these diagonals aren't congruent?
No, parts of them are, but
Oh, sorry, I was thinking about these angles being congruent. So you're saying if these diagonals are congruent. Oh, so if it's just a rhombus that is not a square, this one's kind of obvious. These are obviously not congruent diagonals. These are a bit closer at the top right of your paper. But sure, so grab your straight edge again, but instead of measuring the edges, let's measure diagonal.
I think it is.
From here to here.
I got like 7.8.
Ooh, it looks real close.
7.8 on both.
Yeah, it's looking like it's the same. So we could now make a conjecture that if a rhombus has congruent diagonals, then that rhombus is a square. Do we have to say rhombus, or can we say if a quadrilateral has congruent diagonals?
Congruent diagonals?
Do any other quadrilaterals have congruent diagonals that are not squares?
Quadrilateral has 4 sides, right?
Yeah, rectangles have congruent diagonals.
Ah, rectangles have congruent diagonals.
I'm stupid.
So, what you're saying is, just saying a rectangle plus a rhombus is a square, which you learned in, like, first grade. Is true.
I guarantee you did not learn that in first grade.
I'm almost
And
certain.
2.
Oh, maybe it was second.
It was third.
Well, look at.
So we'll guess.
I was thinking. So,
Alright, well now, getting away from what we did
no, I
yesterday.
did third grade. That's why I'm advanced. It's not because I'm like super smart. It's just because I was in second grade. They were like, "Hey, that kid's pretty smart."
Yeah, same with me. They were like, hey, that kid might be able to do this.
I had to go through a summer.
And then they put me in a third grade class.
Yeah.
And then they put me in the third grade.
Alright, go ahead and flip that paper and actually look at the back that does exist.
You lied to us.
Yes, but it was a very tongue-in-cheek lie.
I don't know what that is.
Tongue-in-cheek is when, like,
You go
I don't know how to define, like, when something is tongue-in-cheek, it's like when you, like, nudge somebody, or when it's like, it's like they're being
You both
sarcastic.
know that the person's
So,
lying.
Yeah, it's like wink, wink, nudge, nudge, like that sort of thing, right? Like,
We're totally not smuggling you.
right? Yeah. Like that guy that got caught last night at my friend's house was probably like, I'm totally not robbing this place. I was just on the front porch to see what they're doing inside. All right.
That's just creepy. Like,
So, opposite sides of a rhombi of a rhombus are parallel.
oh, Rhombi would also.
Now wait, what's a converse statement? Because we got to start talking about converses and seeing.
If opposite sides of a quadrilateral are parallel, it's wait, that's not true. That's
Oh, wait,
if opposite sides of
Wait.
If a shape is a rhombus, then it is a parallelogram.
Do you guys remember converse, inverse, contrapositive?
I forget.
Grab that graph paper you had
Start
yesterday,
with the
or
parallel
if
sides.
you really want, you can write it up here. But I want you to write if A, then B. Graph paper or somewhere. You can use this paper if you really want. Although I think we're probably going to run out of space. So I'm just warning you now. I think I'm about to switch to writing this on graph paper. Theorems. Nah,
I hate it.
it's the sound of learning.
That's funny.
So if the theorem,
Must be different from third grade.
and actually it only happens on this cheaper paper. If the theorem is if some statement A, then, you can't even see what I'm writing, but it's the same thing I already wrote. Then statement B, I bet you guys are faster on the Google than me. Google converse. Like mathematical. Or I can, since you're just staring at me.
Converse is if B then A, right?
Math.
I don't know.
Converse.
Isn't it like,
Are you
inverse?
Googling what
And
the converse
What
is?
is-
The converse is
No,
if
inverse
B
is
then A.
negative. Like, not A. If, no, that's...
It's if B then A. That's what the
And
converse
inverse
is.
is if not A and then not B.
Okay.
And then positive is if not B then not A.
The converse statement is just.
If B then A.
Yeah.
That's what I said. And then the inverse.
Oh
is
yeah.
If not A then not B.
And then
Wait,
positive.
or is the inverse if B then A, and the converse
No,
is not A,
like
it's
it's
not
it's
A.
not.
If
If it's
Which
inverse,
one
then
is
it's
it?
converse.
What does the prefix in mean?
Not.
Like in excited or
Not
in.
excited. Not. Okay.
So
It's not
this
excited, though.
this is also what we nickname our conditional, right? This, and we should know this because any if-then statement is a conditional. If this happens, then this happens. It's got a condition, right? If I bring home Starbucks, then my wife will be happy, right? If I, like, but
You're right,
does that mean that for my wife to be happy, I need to bring home Starbucks? I sure hope not. So that's not a very valid
So
definition.
Isn't that deductive and inductive reasoning or something like that?
Well, now we're getting deeper than just math, and we're getting into like the whole like connection sort of thing. So the converse, what's con mean?
Me.
Opposite.
Or with.
No. Con.
Yeah, con means a few different things. That's the problem.
Illegal.
So the converse is if we flip around the parts of the conditional.
That's what I said.
So I know, but you guys were arguing, so I gave it a minute. So
I
our
said that, like,
converse.
so long ago, though. And then Jake was like bringing up some weird other stuff.
Inverse and contrapositive.
Which is what we're writing next.
I know.
So if B, then A. So if we think about this, converse statement if prove. Ooh, crap. We have to prove it and or say it's not provable.
Sides are parallel and rhombus, not true.
And then
If
isn't
opposite sides are parallel, then it is a rhombus.
If
No.
opposite equals.
Yeah, wait. If opposite sides are parallel, then it is a rhombus.
False. It makes it a parallelogram, not necessarily a rhombus.
So this is not a very good conditional because the converse is not true.
Isn't it if the converse works and the normal one works as biconditional? Or is that?
Yeah. I think she's right.
You guys are such an interesting class to teach because there's no weighting on the textbook. There's absolutely no weighting on anything.
What do you mean there's no weighting on the text?
We're building up to the point where we actually give you all those vocab words and stuff, but you guys are just like, gimme. You're like, so the inverse.
Oh no, this is what Jake was talking about.
If not A, then no. Or no, that's not right.
Yeah.
Yeah, that is right. Wait, can we write this
Inverse
down
is the
earlier?
knots.
And not.
Cannot.
If not, I don't know why I put the not in quotations, but if not A, then not B.
Okay, I was worried you were going to put the not outside of the quotations.
And change my formatting? Yeah, no. Once I've leaned into a format, I'm just leaning into it. So wait, so the inverse of this. If the opposite sides of a... Wait.
If the opposite sides of a rhombus aren't parallel.
Wait.
What is this if then?
If opposite sides of a rhombus.
That's just kind of a fact.
If there are opposite
There's no
sides,
conditional statement.
then the
It's
rhombus
just-
is a
Ah.
parallelogram.
If the sides aren't parallel, it's not a
There's no
rhombus.
condition to this. Except for the rhombus. If not a rhombus, then opposite sides aren't parallel? Wait, is that it?
It's if opposite
If
sides
a
are
shape
parallel.
isn't a rhombus, then its opposite sides aren't parallel. That's it.
Yeah, but
You
that's
guys have...
different.
If
You
there
guys
are
have-
opposite sides, then the rhombus is parallel. No, that's not.
No, it's
And the
not
rhombus is
parallel.
parallel.
You guys have found the issue that I needed you to find.
Which is that this is not worded correctly.
This is not a
Conditional.
conditional. How do we turn this into a conditional?
If a
Then,
shape is a rhombus.
Well, right, but tell me what the
If
A and what...
sides are
if a
parallel.
shape is a rhombus, then its opposite sides are parallel.
Okay, so let's write that then. If a rhombus, and you could say if a shape is a rhombus, but if a rhombus, then opposite sides are parallel.
Is there any shape where all of its sides are parallel?
No, that wouldn't be a polygon. So now that it's a conditional, if we think about the converse, if opposite sides are parallel, then the shape is a rhombus.
We got that.
Yet not true. What about the inverse? If it's not a rhombus, then opposite sides are not parallel.
No, because it could be a parallelogram.
Are all parallelograms rhombuses?
No.
No. So the inverse is bad as well. What about the? Anyone remember the name of the last one?
Positive.
The contrapositive.
Wait, what if we just
If
replace
not
the
B,
word?
then not A.
What if we just replace the word rhombus with parallelogram though?
Now you're changing your conditional.
Exactly.
Yeah, but this is clearly false. So, and then you can just say a rhombus is a parallelogram.
True.
If a parallelogram, you can write two conditionals. One that's this, the other one is a parallelogram has all equal sides.
Is that the desk of shame? I feel like it would.
No, that's Mr. Hall's desk. I'm just waiting for him to open his door again to give it back to him.
Okay.
Dude, I want that desk of shame.
Well, then you won't be able to see the screen. But
What do you mean?
so
You're not sitting in the seat.
interesting. Yeah, I sit there sometimes when I'm teaching, like when it's a full class, because it feels better than way over here trapped in the corner.
Hello?
All right, so theorem. So here's the thing, though. If we're trying to make a theorem, we start with it just being called a conditional,
Yeah.
right? And then if we can prove it, then we work towards making it a theorem.
But we can't prove it because it's not right.
So I kind of want to go ahead and start talking about tomorrow.
Your camera.
So this will be less painful if we split it up, right? And actually, I like two column a lot better than flowchart
I
proofs.
Yes.
love two column. I always do two column in every
So, like,
thing.
it's because you're
Except for the
smart
fact
and
that
it makes more
CPM
sense.
just tells
Yeah, I
us
got
to
it
do
last year, Mr. Hall taught us
I
all
love
that.
that
It's-
Miss Tecklenburg wanted me to do flowcharts, but I was like,
Math 1 requires you to do flowchart
she
proofs.
let me do the two
Hey,
column.
If that flies off and hits somebody or something, you're not allowed to do that ever again in my class. Okay? So just realize, like, if it becomes a thing, it's a thing. And again, you are very distracting to me, but I'm trying to fight it and see how focused I can stay. And you're about to have to write. Because we're going to set up a two-column proof!
Yay!
Why is that?
So, because
it was
flowcharts
better
are
to
silly.
make
Flowchart.
circles and arrows.
It's gross.
I'll take it.
Alright, so he starts by creating the diagram below, copy the diagram. So let's go ahead and throw this parallelogram onto our paper. At least it looks like a parallelogram.
The suspicious shape.
Ansel has done a lot of proofs using congruent triangles. Now he wants to challenge himself and prove the conjecture. Opposite angles of a parallelogram, oh, okay, that's assumed, are congruent. But we cannot use triangles to do so,
Why not?
because that's our goal.
Okay.
So we have WTUV. Let's all copy this so our labeling agrees with each other. So angle A, angle C. Angle B is going to be the exterior angle, so you can draw that dotted line if you would like. You can use one of those shapes templates if you want to run up and grab one. I think I put mine away yesterday. But you can also just use your graph paper to draw a parallelogram, because it's not that bad to draw a parallelogram on graph paper.
Yeah, they're such a difficult shape, you know. Like, I can't draw a parallelogram. Why is B, like, out there, like a weird one?
Because it is the exterior angle.
Oh, C and B. Oh.
So here's the thing about two-column proofs that has me worried about you guys. You guys like to operate... Well, first off, you guys like to interrupt me and not listen, so that's one concern to start. But you guys like to operate using the assumptions, which I get, 100%. Although, in mathematics, we have to write down those assumptions so people that are less smart than we are can figure out what we've already figured out. Like gravity is a constant, and apparently Connor's losing the battle.
I refuse.
You refuse?
I refuse. Yeah, I'm walking on the ceiling now.
Give you about 30 seconds to figure that out while I drink coffee.
Why is this so funny?
So we'll take time to do your homework once you collect yourself and like we can actually solve a problem together. So we in a two-column proof have two columns. Oh, big surprise! And they are labeled statement, statement, and reason. Now the fun of a two-column proof, yes, he said fun, is that we get to start with the reason of given, which is kind of like because I said so. Right? So that is kind of fun. But whatever the problem tells us is true is what we start with as given. So what do we know is our given here?
Woodtube is a parallel.
Woodtube is a parallelogram. So we can say WTUV is a parallelogram. But then this is where I'm worried about you guys. Because then we have to start saying, like writing down the stuff that the given tells us. And as we do it, we normally throw those labels onto our diagram. So like, what do we know because WTUV is a parallelogram?
TU is parallel. Oh, sorry.
Sure. TU is parallel to WV. And actually, we can put multiple things together. So yeah, TU is parallel to WV. What else?
Do we have to say that though?
It's better to write it down because someone dumb.
No, I mean, no, I understand.
Correct.
like,
TW.
But what I'm more saying is, do we actually need to
Yes.
know that?
This is why I'm worried about you guys. Yes, you do have to write it down. And yes, you have to give the reason, which here, what reason would justify that? Definition of parallelogram.
No, I understand that if we're going to use it, we need to write it down. What I don't understand is why we would need to use it.
Well, that's for you to figure out. Are we going to be able to solve this without using triangles and without using the parallel sides? I doubt it.
Well, no, yes, we do need one pair of parallel sides. What I'm saying is,
We can say that.
writing down both of them just seems a bit, like, unnecessary.
Okay. And you can think that for right now. We'll circle back to that question at the end and decide was it necessary or not.
It is necessary,
Angle
actually.
A is congruent to angle B, but
It's not.
It is.
But it's
Oh,
alternate
yeah.
interior.
We need to prove that C and B are corresponding.
I think we should put group C is concurrent because corresponding.
Oh yeah. Corresponding.
So make sure we label that it's angle C congruent to angle B. Why?
Corresponding.
Yeah, so our reason, we just write down corresponding angles.
Do we have to put theorem after all the theorems?
No, well, not for me.
Okay.
And actually, for the state, it'll probably all be multiple choice.
Wait, really?
Yeah,
Dude,
I think
love
you
multiple
put the
choice.
the theorem or proof inside the box.
It'll be like drag the thing
that's
over
what I
here.
do.
You'll be like dragging stuff around to fill in the two column. All right, so B is congruent to C, but that doesn't help us because
And
we
then
need to prove.
Angle A is congruent to B because of alternate interior angles.
Angle A is congruent to angle B. And our reason was alternate interior.
And then angle C is congruent to angle B for substitution.
You mean A?
Oh yeah, C is congruent to A.
That was a property, right?
That's a fun one.
Yeah, substitution property of equality. Or really, you could use transitive property. Well, no, transitive is normally when something's bigger.
Did I put PT larger property?
Normally we abbreviate it crop, like PROP.
I was
Do
so
we have to
used-
put prop? Or
I'm
can we
used
say
to
it's
doing
substitute?
PTY.
For me, I don't care. You just put substitution.
Okay. And I don't think we needed TW as parallel to U.
Jake, earlier you said yes, we do. Do you want to justify why we do need that?
The parallel sides?
Yeah, why do we need TW and UV, not just TU and WV?
Oh,
We don't.
we do.
Oh my
Okay.
god.
Oh, yeah, we do. Yeah.
Both of you are flip-floppers!
We do need it. I get it.
Why do we need it?
Because there's two ways that we're doing things.
Two ways that we're doing.
Because for the corresponding angles, the parallel lines we're using is...
The only way that these angles are corresponding. This is a straight line. Straight lines are assumed to be straight, right? And if you extend a straight line, it stays straight. Those are assumptions we're allowed to make. But C and B are not corresponding unless the lines are parallel. So we use this.
Are not alternate interior unless the lines.
Ah, we use this for the corresponding, and we use this for the alternate interiors.
Whoa, that is crazy.
Also, I like this much better. Oh wait, you can just do a T-chart instead of drawing the box around the. Oh.
I'm here to make your life easier by assigning you nightly homework and making you solve more and more difficult problems. But yes,
Oh, it's not.
I am here to make your life easier. All right, so we'll jump back into two-column proofs tomorrow. You got like.
It's a tie.
Well, so I'm debating because it was really, really close right before winter break, but it was kind of flawed because people were gone on trips. So it literally came down to like 93% versus 94%. And I feel kind of dirty, like giving it with that close of a thing. I don't really feel like one class beat the other class. It just came down to how many kids were in their class. Like, what was the denominator?
Wait, so here's what you do. You just give everyone a prize. Participation.
Well, my thought is those two classes will compete for like first place in the homework contest, and I don't know.
And then we get a prize too.
Does second place also get a prize?
That cool.
I don't know,
Because,
probably.
like, they were very close.
I mean, normally when I give out prizes, I give stuff to everybody anyways.
He does, because we won, and then he
Wait,
gave
so
everyone.
what's the point of winning?
Yeah, it is.
Well, no, it's a lesser prize.
Oh.
Because he gave.
It's not true socialism if it's not equal.
Oh.
Because it was like, y'all get an ice cream sundae bar, y'all get ice cream sandwiches. Which actually, you should remember that. I gave you ice cream sandwiches last year.
You didn't.
Yes, I did. Or was it 2 years ago? I think you're lying. I think we did.
You're a
You
liar.
had an ice cream sundae.
Wait, James, I remember us
While you were having your sundaes, the other kids had their sandwiches.
No. People at lunch got
I
their
think
ice
I
cream
remember
sandwiches.
that day.
While I had to watch them eat it in front of my face, and then in math.
Yeah, I know.
Yeah.
So I didn't give ice cream sandwiches to the people who also got ice cream
I know.
sundaes.
I know.
You greedy little person. Hey, 8th is at 12:20 if somebody wants to.
Oh, sure. Do we have a board?
Yes.
Do you only have one board that you change, or do you just keep
Yeah, you only have yours with one.
That just seems inefficient to me.
You can just change it to.
I don't know where the marker is.
Oh my god.
Do you have a marker, Mr. Hudson? Where's the marker?
Right here. Or, I mean, I think there's normally some on the boards, but.